What's going on, everybody, and welcome to part 4 of the ML in Halite 3 tutorials. Where we left off, we were creating, for real, hopefully this time, some training data. I'm going to be pretty angry if this is not correct, but we checked it last time and I think I'm all set. Anyways, what I've got here is actually over 50,000 files and almost 50 gigabytes of training data. I think we're all set, so I'm going to go ahead and stop all these from running. And we'll close these, and we'll pop into here, come into training data, and let's sort by size. Make sure, looks like they're all between 1004 and 1006. Want to make sure none of them are just like empty. And then we can also sort by the name. Looks like the largest is just under 5,500, but pretty quickly, I mean, we only have a handful of 1,000 Halite games, like where the AI somehow collected over 1,000, which is pretty impressive. Because recall, we're only making one ship, so that starts us at 5,000, one ship goes down to 4,000, and we set this threshold to save as just basically 4,100, so did that ship collect any Halite? Now what we want to do is find out where should we draw the line? So for example, let's come into, oops, this is just the data. I don't really care about that. Let's go, oh, we're, idiot. Okay, so I am, I guess we could take testing grounds. I think we'll just modify testing grounds because there are a couple of things I want to check. So the first thing would be, let's do import OS, and then all files equals os.lister training data. Don't forget to put this in quotes. And what I'd like to do, import matplotlib .pyplot as plt. And what I want to do, actually this machine probably doesn't even have matplotlib, so let's go ahead and grab that. Let me make sure pip is to Python that we're using. Hurry up. Okay, pip install matplotlib. So we'll grab matplotlib. Make sure we can. We should be good though. I just want to make sure no errors. And what I'd like to do is plot like a distribution of the scores, kind of for two reasons. One is I'm just curious right now, but also what we could do is keep this exact same threshold, and then after we've trained a model, we can see is the distribution exactly the same, as in like almost like what's the average score of the games. You also could do an average, but or both. I'm curious to know after we train a model, how much better is our new model? So coming back over here, all files, os.lister, train data, let's just print len all files, run that really quick. Let's see how quickly we can get through that pretty darn fast. So then for F, because if we use file, I think that's I thought file was a keyword. Anyway, I'm going to keep with F. For F, in all files. So that should be the file name. So then we just want to say Halite amount equals f.split. We'll split by the dash, and then we'll go with the 0th element. So if we print Halite amount, we'll just break after the first one. Break. We can see 4,100. So then I'll just do Halite amounts here. Then we will delete to here. Halite amounts append Halite amount print. Let's do println Halite underscore amounts. Also, just so I can dev this to start, let's just do like 500. Cool. Okay, so now we want to plot a histogram. I believe it's plt.hist in matplotlib, and then for a histogram you just have to pass x's. So we want to pass Halite amounts, and then it's like bins. It might be H bins or N bins? We're going to find out in a second. I'm going to say 5. And then plt.show, run that. Woo, it worked. Okay, so it's only 4100 because as we iterate, I think we're just going in an order. So let's do 15. Let's do 1500 first. Just see. Okay, so we can see clearly the most common is 4100, and then it kind of goes down. Let's do them all. I think that's looking pretty darn good. I'm actually not sure why that was so difficult. Why would that be so challenging for it? Because we said we only wanted so many bins. So why is the display so challenging for it? Huh. It's curious. What have I done wrong? I feel like it didn't actually put them in the bins. Right? Halite bin. Let me pull it up real quick. I don't know what I've done wrong here. Let's do matplotlib histogram. Pyplot hist, that's correct. See, if we say, 5 bins, it really should only have like 5, categories of bin. Clearly it wanted to label like a bajillion. Could you please not take 5 years to load and just, I don't know, load? Any of them? Oh, these are all matplotlib.org. What about this one? This isn't matplotlib. Or, yeah, there we go. Yeah, how come their bins look normal? Num bins. X num bins. How come mine is so ugly? Highlight amount bins equals 5. Just to make sure bins is the keyword. It looks like that person passed. Yeah, it's still going to be a pain, isn't it? Weird. I don't know what I've done. I thought with the bins it would just show, it would be like the range almost. But that doesn't appear to be the case. Yeah, we got like all these million tick marks. Someone comment below what I've done wrong. It's kind of a bummer. I'll keep these around though. I'll keep the script. The other thing we could do is, I think it's from, is it statistics that has the mean operation? From statistics, import mean. For now, I'm just going to comment this out, I guess, because I don't think that's really working. Print mean highlight amounts. What? What's wrong? Oh, dude. Okay, so I bet I know what I've done wrong up here. Let's see. So right now, these are not, this needs to be an integer because right now it's a string. Let's see if that fixed it. Woo! Oh man, what a dumb mistake. Okay. Okay, so this sort of helps. I'd probably cut it off at about the 10,000 mark just to see what the real distribution is, but as you can see, it's pretty significant, or even maybe 2,000 mark or something. But you can see we got very few of these games, and then it ticks up real fast. Okay, cool. So then the other thing we really could do now is this, and we get the mean, which is 4202. So that's the average. So later, after we train a model, we can come back and see what is the new mean. Okay, so so now that we've done that, what I'm going to do is I'm going to come in here, training data old. This is from before. So over time, I'll probably keep at least the previous training data set. Obviously, it's 50 gigabytes. At some point, we can't be doing that. And soon, we're going to have multiple ships, and we're just going to have huge data sets. So we can't keep too many of them. Normally, I probably won't have 50,000 games, though. That's a lot of games. so really, we would just raise the threshold probably. But for now, I do want to see if we can improve the mean game from one training example. So testing grounds, instead of calling that testing grounds now, what I'd like to call it, I'm not sure why I had to save it. Let me just test it real quick here. cool. What we're going to call this instead now, we're going to just copy paste. I don't know. Why do we have another test? Oh, this is the output. Okay. Coming back over here. I'm going to get rid of test because it's just taking up space. Also, centibot2. I think we only needed that for testing as well. I'm going to delete that. This, I'm going to say, let's call this training data distribution. Cool. Okay, so now let me just copy and paste either of these, and we'll call this centitrain. I don't know. Anyway, basically it's going to train. We'll use this to be our training script. Okay, so to train, I'm going to use TensorFlow. You could also use straight Keras. I'm going to use Keras from TensorFlow. But you can do whatever you want. If you don't know much about Keras and TensorFlow and all that, you can always go to pythonprogramming.net. Finally, it knows that one over. You could type in Keras and then come down here and learn all about it. Cool. Okay, so wow, we still can't get to matplot. This has been happening for like years where like I just can't access matplotlib.org sometimes. I really wish they would figure out what the heck's going on there. Anyway, I think we're done there. We'll open up a browser if we need it later. So anyways, let's get started. Import TensorFlow as T. I hate that Sublime does that to me. Import TensorFlow as TF. We're going to use OS. We're going to probably use NumPy as NP. We're going to import time. We are going to probably need random. We need random to like shuffle. To my knowledge, there is no shuffle for secrets. You can modify secrets to an extent to have a shuffle, but that's not really the point of the secrets module, so they don't have one. We're also going to, from tqdm, import tqdm, which I don't have tqdm, so let's go ahead and pip install tqdm. This just gives us a nice progress bar as you're doing things. Since we have so many files, as we iterate, it would be nice to know where are we in this freaking process. Okay, now from tensor, and in fact, I'm not sure I can do this any faster than I can write it, but I might be able to. So let's go to pythonprogramming.net. Let's go back to that Keras series, because you always just need like the same freaking imports. So let's go down to how to use your trained model, optimizing models. Maybe let's do part 3 here. So convolutional neural networks. Let's see what the imports are to this statement. Dang, who did these awesome freaking pictures? Yeah, basically all of this, these like sequential, dense, dropout, activation, flatten, conv 2D, max pooling 2D, we need all that. And I don't really see any point in typing all that out. Pretty sure this is faster. Okay, so the only other thing that we want is going to be from tensorflow.keras.callbacks. We want to import tensor board. And this is so we can display the beautiful, beautiful graphs as we go. Okay, so I think we're ready. So now, as we build out this model, we have a few things that we need to do. We basically, the data set is too big to load into memory, first of all. We can chunk it down probably and actually load the entire set onto a GPU, at least in the setting that it's in right now. But I know if anybody's following along and you don't have, say, a 24 gigabyte GPU or a 12 or whatever, and you can't fit it into memory, it's important that we batch it in. Now, I know Keras has some sort of generator and you can load it in, and I've done stuff with that before, but then when I need to start customizing stuff, that's where it starts getting unbelievably complicated, so I just don't do it that way. If you want to use the generator and post how you would do it, go for it. I just find it adds undue complexity to a problem. And like in this case, I'm just trying to do like testing here. I'm not trying to spend 5 days figuring out how I can create a custom generator that loads batches of files. So anyway, not going to do it. But yeah, if you want to do it, go for it. Have fun. So the first thing I'm going to say is load train files, and I'm going to set that to be false. So basically true if we already have batch train files, I guess I'll call this train files. This will make a little more sense when we get there, but basically we are going to take these files, because keep in mind, these are only 1 megabyte, right, the training data. So we're going to want to load, you know, probably 50, 100, 200. You could load quite a few, even like 1,000 of these, and it's no big deal probably, depending on what size your memory is. So, but over time, the games are going to get much, much bigger, because right now we're only going for 50 turns, and we only have 1 ship. Now imagine later on, we've got 500 turns, so it's already 10 megabytes. And then imagine you've got 10 ships. Well, that's 100 megabytes right there per game. So eventually, it's going to be even more important that we batch these files. So that's what I'm just going to do that from the very beginning. So for now, it'll be false. And then also, like, if you're going to train for more than 1 epoch, or you want to train and then tinker some things and train again, what we can do is, as we load and kind of combine everything and do the balancing and all that stuff, we only really need to do that 1 time. So it would be useful to save it when we're done, because that's going to take probably longer than the training is going to take, at least for a small model. So then we're also going to load, whoops, I meant to keep the caps on, load prev model. Again, I'm going to set to false, but true if you want to transfer learn from existing model. Okay, something like that. I have to fix these. Okay, so now the final thing is over time, like right now, I just have a Halite threshold. So for example, we could say, you know, Halite threshold, and initially it was 4100. Over time, we might want to change that. So I'm going to leave that for now, and we'll come back to that number, because again, we're probably going to end up changing that to something a little more dynamic as well. So then also we need a training chunk size. And for now, I think we can set that to be, even 100 is pretty good. Probably 100 or even maybe 200. That'd be 200 megabytes, more than, you know, totally easy to fit onto just about any GPU, no problem. We might even want it that larger. I'm going to go with 500. Okay, so then if you have one, prev, oops, that's not what I wanted. I want prev model name. For now, I'm just going to leave that empty because we don't actually have one. Then let's think here. I guess we would want a validation game count. We'll set that to be, like, how many games do we want to use for validation? I think I'll say 50. That means like 10% of each training chunk would be a validation. 50 might be a little large, but I'll go with 50. That's fine. Okay, so then we'll choose a name for this model. So how are we going to save it? Blah, blah, blah. I'm going to say this. I'm going to call it phase 1 dash. And then for now, let's just throw in int time.time. So that'll be the name of the model. And then finally, epochs. Let's just do 1 epoch. I don't really see any reason why we need to do a bunch. Then training data dir equals training data. Fix this D. Cool. Okay, so now what we want to do is iterate over our training data, and basically we first need to get all of the files. So training data names, or training, let's call this training file names. And for now that'll be an empty list, import, oh wait, we've already got OS. That's not where you want to import it. For F, and actually let's just, oh, was it in here? For F in os.lister, so I don't really want to copy that exact thing. Sent to train. So let's do for F in os.list dir training data dir. Then what we want to say is basically the, we'll say the, let's say Halite equals, and then that split, this. So we'll say Halite amount equals that split, and then we'll ask the question if Halite amount is greater than or equal to the Halite threshold that we set. If that's the case, then what we want to do is say training file names. We want to append os.path.join the training data dir and that file name, so f. Okay, now print. Let's just say after the threshold we have len training file names files. And actually we should call this games. Okay, so run that again. Make sure all that works. Kind of surprised how long that's taking. I wouldn't expect that to take very long. Okay, so we have all the games. So what if we, so clearly 4,100, we don't need 52,000 games, especially for this first step. So what if we said 4,500? Because we did see how few games we had after the, so 1455. So we want a little more, that, like my target's about 2,000. So let's try 4,400. Oh, wow. So how about 4,450? Okay, I think we'll go with, it's hard to say, 40. I don't know if it would be better to have the extra games. I'll go with 4,400, just so we have plenty of games to learn from. I think that makes the most sense. Okay, so with 32, 35 games, that gives us a little over 150,000 samples to learn from. Of course, most of those are just random and worthless, but hopefully some of them will be somewhat decent. And after only 50 turns, most of the moves, or at least a large number of those moves, were actually probably pretty useful if we were able to gain 400 Halite from it with only one ship. I think that's okay. So, so at this point, we would want to random.shuffle those training file names, because as you saw before, they go in perfect order. I'm not really sure we want to do that. So random.shuffle training file names. Okay, and then at this point, I think what I want to do is probably stop it here, because the next point is really for us to balance and then train the data. And I think if I'm going to do that, I probably should split this off. Because the balance is definitely going to take a considerable amount of code. The model shouldn't take too much. In fact, we could probably copy and paste again from Makaros page and be good there. Yeah, I think for the balance, I'm going to split that away. So anyways, I'm going to stop it here, and in the next tutorial, what we'll do is you want to get to the point where you balance. Now, this data probably is already pretty well balanced because it was a random choice, and a pretty good random because we use secrets.choice. So actually for this step, for the first step, we actually probably don't need to shuffle the data, or I'm sorry, balance the data, because there is probably an equal amount of like go up and left and right and down and don't move. There's probably an equal amount of those because it was just randomly selected for. There might be a slight weight towards different things, like for example, I think in Halite, you might, depending on, if the ship went left or right, like if most of the Halite was, over in one direction, you'd have way more turns or steps in that direction. Also probably still, like hold still, maybe one of the more common moves because you're like waiting on a plot of Halite. I don't really know. Anyway, regardless, we have to balance at some point. So might as well just throw in the code to do that now. So yeah, that's what we'll do in the next tutorial. So if you've got questions, comments, concerns, whatever, feel free to leave them below. yeah, otherwise, I will see you guys in the next video where we balance, create the model, and hopefully start the training process. And it shouldn't, maybe in that training process, I'll just pause it while it trains. It shouldn't take too long to train, especially with only this many games, but we'll see. Anyways, see you in the next video.